Hey guys, welcome back to another video. So here we're going to be sketching reciprocal functions. So basically if they give you a function f of x and ask you to sketch 1 over f of x, well, this is how you do it. So this is a continuation of two other videos which I made previously. One is how to sketch the basic functions such as exponential functions, logarithmic functions, obviously all the polynomial functions, and modulus, inverse functions, hybrid functions, and the whole lot. In the second video where I covered in detail rational functions, this specifically I recommend you check out because reciprocal functions follow somewhat the same rules as this. Rational functions are basically any function in the form y is equal to f of x over g of x, where g of x is not equal to 0. So reciprocal functions in theory are just, well, rational functions where f of x is equal to 1. So yeah, this is more of a specific case study within rational functions, but yeah, it's definitely important and I recommend you check out the first video. So how do you go about sketching reciprocal functions? This first step is to sketch f of x itself. So this is not part of the graph, but this is just for reference. So you gotta sketch f of x. And the second step is to know that all of the original function will become vertical asymptotes. Why is this? Let's take a graph, a quadratic graph, and at these 2 points, let's take these 2 points are x1 comma 0 and x2 comma 0. So at these 2 points, well, f of x is equal to 0. And if you watched the previous video, if you have any idea about like imaginary functions and stuff, well, if the denominator is 0, well, an asymptote exists at that point, because an asymptote is basically any point at which there are no real solutions to the function. So at these 2 points, well, f of x is equal to 0 and therefore vertical asymptotes exist. And secondly, you have to know that all the vertical asymptotes of the original function become, well, x-intercepts. So now we can look at a function where, for example, you can look at this function where let this be x is equal to 1. That is the vertical asymptote. At this point, well, it's 1 and infinity. If f of x is equal to infinity, if you substitute that into the reciprocal function, 1 over infinity would be nothing but 0. So when this is a basic rule that you have to know, that 1 over anything over 0 is equal to infinity, and therefore if you bring infinity over here and 0 over here, well, 1 over infinity would be equal to 0. That's why all the vertical asymptotes of the original function become x-intercepts of the reciprocal function. Well, now the third step is to calculate the horizontal asymptote. You can do this using the limit method, which I covered in the previous video, where you limit x tends to infinity and then 1 over f of x, and you can use this to find the value of y for which x tends to infinity. In this case, the notation should be something more like limit f of x tends to infinity, because yeah, it's no longer y is equal to f of x, but rather y is equal to 1 over f of x. So it's a new function, and 1 over f of x. So how exactly would you do this is, let's take an example at this. So at this point, I think it's important that I introduce an example so that you can understand what's going on much better. So let's take a quadratic function perhaps, and x squared plus 2x minus 3. So if you guys don't know how to sketch this, well, you guys should check out the first video I made. And yeah, it's in the description. I won't be delving too deep in this video. I'll just be sketching it myself so that we can save time. So this is what the graph looks like. So now we're gonna sketch 1 over f of x. So we have all the key points written down. So according to the rules, well, all the x-intercepts become vertical asymptotes. So in the case of 1 over f of x, the graph would look something like, let me draw the axes. Then the x-intercepts minus 3, so let me just, and 1. These are super rough sketches, so scale. And then we noted that all the vertical asymptotes will become x-intercepts. So obviously there were no vertical asymptotes in a quadratic function, and therefore it's safe to say that there are no x-intercepts. And since there are no x-intercepts, well, we know that y is equal to 0 would actually be the horizontal asymptote. This is true for most quadratic functions. And so basically, quadratic functions do not have any asymptotes, and therefore, since they don't have any vertical asymptotes, well, the reciprocal of quadratic functions, which is, in this case, let me just write down the function. Let's take it as g of x is equal to 1 over x square plus 2x minus 3. So basically these do not have any x-intercept. So from that we can easily assume that y is equal to 0 is actually the horizontal asymptote. So, but if it wasn't a quadratic function, well, you actually have to go through the limit method, which I mentioned in the previous video, to figure out the horizontal asymptote. So let me just go through the way, how to find the horizontal asymptote if in case it wasn't a quadratic function. So basically you need to limit f of y is equal to limit of f of x tends to infinity by 1 over. So yeah, and one more thing, in the previous video I mentioned that if the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is always at y is equal to 0. So in the case of reciprocal functions where the numerator is always 1, well, we automatically know that the horizontal asymptote is at y is equal to 0. But if the numerator was different, for example, and had an x term, well, how exactly do you go about finding the horizontal asymptote? Well, you use the limit method or the different conditions which I mentioned in the previous video. So go check that out. So in this case, I'm not gonna, since we know that y is equal to 0 is the horizontal asymptote, we can begin sketching the graph. So, so next step is to calculate the y-intercept, and this might not be possible every single time. For some graphs, there might not be any y-intercept, but in this case there is a y-intercept. So let's calculate the y-intercept. To do this, basically you take x is equal to 0 and substitute it into the function. So you get 1 over, so y is equal to 1 over 0 square plus 2 into 0 minus 3. So y is equal to negative 1 over 3. So now we know that somewhere over here the graph intersects the y-axis. So now we have the y-intercept. And lastly, one last thing you have to understand is how the shape actually differs between f of x and 1 over f of x. If in a specific region, let's take from negative infinity to negative 3, in this region, if the graph is decreasing, well, in 1 over f of x, the graph would be increasing. And likewise over here, if the graph is between negative 3 and 1, if the graph decreases, reaches a minima and then increases, well, in 1 over f of x it will increase, reach a maxima, then decrease again. And likewise at the domain x is equal to 1 to x is equal to positive infinity, the graph is increasing infinitely. So basically in the case of 1 over f of x, the graph would be decreasing. So that is a rule of thumb which you can understand to sketch these graphs easily. So how would the graph actually look like? So let's begin sketching. So first let's look at the region of x, region between x is equal to negative infinity and x is equal to minus 3. Well, since we know that the graph is decreasing, over here obviously the graph has to be increasing, and we know that there are two asymptotes, the horizontal asymptote at y is equal to 0 and the vertical asymptote at x is equal to negative 3. So basically we need to sketch an increasing function which does not touch these two asymptotes, and there is no other option apart from this. So the first region is done. So we just need to assume that, well, it keeps going towards these asymptotes. And now the next region, well, we know that in f of x the graph is decreasing, touching a minima, and then from the minima point it is increasing again. So over here it needs to be the exact opposite, and we need to intercept with the value -1/3. So how do we do that? So first part is decreasing, so we increase, the function is increasing and hits a maximum point, and to find the maximum point we just take 1 over the minimum point which the original function touched. So the minimum point was -4, so basically it's -1/4. It's somewhere over here, and then after it hits that point it begins coming down. It intercepts with the y-intercept and then follows this shape. As it's an asymptote, it cannot touch. So it's basically the inverse of what happened between the same points in the original function. Now in the region of x is equal to 1 to x is equal to positive infinity, in the original graph, well, it's the graph is increasing infinitely. So in the reciprocal graph, the graph has to be decreasing infinitely, and it cannot touch the two asymptotes. So it goes something like this. So yeah, that's how you sketch reciprocal function. As you can see, it's actually very similar to the rational functions which we looked at earlier, just that f of x is equal to 1. So I strongly recommend that you check out that video to see all the different possibilities in which they can ask, because this is just a subset of that, but definitely an important subset. And by knowing the similarities between a function and its reciprocal, by knowing that, you can quickly sketch the graph, and therefore I think that's super important. And I hope this video was helpful. Definitely check out all the previous videos, and there's one more video which I'll be making on transformations, where like we take this function or like any of the functions which I've discussed before in the previous two videos, and we transform it by like adding a constant or subtracting a constant, maybe even multiplying or dividing by a constant, and then sketching the modified version. So yeah, most of your questions would not be the basic e power x or log x, but rather 2e power x or e power negative x, something like that, something modified. And therefore I recommend that you guys check out that video as well. So thanks for watching, and I hope this video helped you guys.